Well, if you watched my last video, you saw the rework of that bumper on this fire truck. The next thing we're going to tackle on it, and I'm going to do it as a separate thing, because it is kind of a separate thing. Next thing we're going to get into is fixing this 2.5 inch line. Very strange the way they did that, and I'm still boggled as to how they were able to get that hose on there. The only thing I could figure out is they've slid that hose on there and then hooked it up to the fittings, or they had this pump completely unbolted and they hooked it up and then forced the pump into place. Either way, we're not leaving it like that. I've got some parts where I can put a couple unions in it, and I'm going to fabricate a couple sections of pipe that's got miters, a couple of miter cuts in it to fix this so that it's at least not that kind of an offset. I took an impact gun and took the bolt section completely out of those clamps, and they wouldn't come undone. And then I used this other clamp removal tool right here, and man, it came right apart. That was extremely effective. Well, as good as that clamp removal tool worked, I'm going to get out my hose removal tool, see how it does. It might do a pretty good doozing if we can get a proper doozination out of it. Then we'll get this apart. There we go. Yeah. Nice hose removal tool. Got my 36-inch aluminum rigid pipe wrench on that one nipple. Pull as hard as I can, and it ain't moving. This might be interesting. Put a lot of stuff like this together, threading with a pipe wrench in the drilling industry, and it does seem like it's often in a cramped area, and you want that pipe wrench to work where you can just go. And a lot of times if your pipe wrench isn't set just right, or if you're not thumbing it right, when you try to back off and get another bite, it'll turn the fitting backwards, and then you're not getting anywhere. I want to see if I can show you, or maybe you can see what I'm doing. See, I want this to release. I'm taking my thumb and I'm pressing in. Come all the way back as far as I can. Now I'm taking my thumb and I'm pulling it towards me. That's making it bite. Right there it bit and tightened. This is all the space I've got to crank my wrench, so I need to get as much as I can. Loose. Tight. Loose. Tight. Loose. Tight. The way I'm using my thumb right there, it makes it so that I'm getting as much as I can get out of each bite. So I got them old pipes out. I got a nipple and a union threaded into each side. And one thing I can do where I'm looking at this, I can stick my tape measure in here right inside that nipple and pull it out till I fall off the end of the nipple, which is right there. Right there. So it looks like holding my tape at the end of that nipple that's in there, I measure the end of the union and I'm getting about 2.5, 2 3/8, 2.5. And the full length, if I measure this whole union, I'm getting about 3 1/4. What that tells me is that on this particular deal, that nipple is threaded into that union about 3/4 of an inch. So that's something I can keep in mind as I go on. Now we know we measured the offset there before, and we had 1 1/4 inch offset. And there is a little bit of roll, and like I said, I'm not gonna worry about the roll because I can adjust that as I turn things. But what I'm getting when I measure union to union here is I'm getting about 10 1/2. Maybe 10 5/8. That'd probably be 10 1/2 if I had it angled there right. So if I had the 10 1/2 inches from that union to that union, and then I figure it's going to go in that one 3/4, it's going to go in that one 3/4. That'd be 12. 12 inches as a total. So here we are with what I'm going to call a 12-inch run. The total length of 12 inches. From the end of a thread to the end of a thread, and a 1 1/4 inch offset. And if we look at it at the view I'm looking at right now, we can tell that there's also some roll. Like if we were putting parts together that were square, we would have compound miters to make it right. I'm not really going to concern myself with the fact that pipe is almost on a level plane and this one is coming slightly downhill. The reason I'm not going to worry about that too much is because of the fact that we're talking about, a pipe that's round, that we can rotate. And also on these unions, in order to connect it, we can roll that around and make some adjustments there. So all I'm going to do you got to start somewhere, and I'm going to do a layout I'm going to do a layout of a 12-inch run on this with a 1 1/4 inch offset, and I'll have to consider that I'm going to use this nipple right here, and it has to be straight for a certain amount because of the threads. And another thing is I don't want to weld too close to the threads. if I have a miter cut that comes clear back into the threads, that's no good. So I'm going to say I've got about 1.5 inches of threads. And I want to be at least 1 inch in from those threads on the short point. So we're going to be 2.5 inches on the short side at least to where we can have a miter cut. So let's take a look at what we can do for that. Got my bevel square here, and my bevel square showed me where I'd made a mistake earlier. I went my 2.5 inches to the short point here to here, and then I went 2.5 inches long point here to here. Well, this shouldn't be 2.5 inches. The short point's up here, so this should be 2.5. This would be longer. It's no big deal on a little one like this, but I put my bevel square up there, and I went from the intersection I got here and here, and then set my bevel, and then when I come over here it was different. That's why you draw you a little picture. It's easy to adjust. Right now I made an adjustment because I know my offset's right, or close. With the red pencil, I'm going to mark this angle. Lined up with my 2.5 up here. Gonna call that my angle cut and try a couple and see how we come out. So I just loosened up the fence on this saw, put the bevel square down, line that blade up, and lock the fence down. And I got quite a bit of this thin 3-inch wide flat bar. I'll cut some pieces of it first, and that'll give me some little test without wasting my pipe. And I can use the layout here and get me an idea on length. So the long point of the first piece is 2 7/8 to the long point from the square point. And then from long point to short point on the rake is 6 3/4. And then that last piece, you know, it should be the same. We'll go the 2 7/8 on it. So 2 7/8 square point to long point, 2 7/8 square point to long point, 6 3/4 long point to short point. This is one of the times when it's really nice having 2 of these saws set up. You just seen me cut those couple miters, and I've got this miter cut on the end of here. But at this point I need to cut this off square because this would be the square end. The thing is, if that miter that I've got set on my saw works, I'd really rather leave it alone. So I'm going to take this piece down to that other saw that's set on 90 degrees and cut this. That way I can leave that. This one will be set on the miter, and that one can do any square cuts I need to do without changing the saw. We're doing some miter cuts, Miss Diane. What do you think of that, Miss Princess? So to keep this simple without getting into degrees and all of that, how many degrees and dividing the degrees to figure the miter, we didn't need to do all that on something like this. We know we got 1 1/4 inch offset, and we got a 12-inch run. So we got a line, then draw the 1 1/4 offset, which would give you this line. Then draw in your OD, 3 inches, line, 3 inches, 3 inches, line, 3 inches, 3 inches, line. So now you got 1 1/4 inch offset on 12 inches. A 3-inch OD pipe, you're going 3 inches like this, like this, like this, and you get an idea of your miter cut. Set your miter cut with your bevel square. Use your bevel square to set your saw. I cut some test pieces. Looks like it's good enough. Let's cut some pipe. 2 7/8 to the long point. Another one, 2 7/8 to the long point. Now with my 2 threaded ends cut, I went ahead and took those unions apart. Brought them right over here. The pieces that those threaded ends go into, I went ahead and doped them up good and started them in there. And what I want to do, I want to make it easy on myself. Not only make it easy to tighten these up while they're little like this, But the other thing is, I don't want to have to try to put that short of a piece in some kind of a pipe vise or anything, because you could probably squish it and make it oval. I got me a piece of angle iron clamped down, and I'm just gonna tack that on there temporarily. And this is a real good position where I can take my 36-inch pipe wrench and get that tight without any problem. Easy to reach instead of fighting with it up in there. So I'm going to go ahead and tighten these onto the fittings where they go. And since I'm going to do that, I'll have that ready. I could go ahead and put those in place up there on the truck. And you remember I cut that piece of flat bar that's supposed to be the middle piece. I could use this flat bar to hold in there and see how it fits before I cut that center piece of pipe. Maybe I want to make it a little longer or fudge it a little bit to make it fit better. So we'll do that before we cut that other pipe, and we can make an adjustment if necessary. Now already I would make a guess that we're going to be really glad we didn't go ahead and cut that center piece of pipe, because I think that center piece of pipe is going to have to be made longer than the 6 3/4 that we got in our layout. The reason why I'm saying that is we got a measurement off of those brand new nipples that showed that the nipple went into the union 3/4 of an inch, and I can see where I've just threaded this on that used nipple. It's went in way more than 3/4 of an inch, and that would make that center piece right there come out longer, because we were only figuring 3/4 of an inch on each side for a total of 1.5 inches. We had 10.5 inches when we measured from the one union to the other. We had 10.5, and I added 1.5 inches for 3/4 of thread going into the union on each one, and that threaded in way more than that. So I think we're going to be glad that we didn't go ahead and cut that center piece of pipe. And this is another good reason why on something little simple like this, it's not worth getting down to the degrees and figuring everything, because there's variables like this that are just, it's going to make it where it's not worth getting that particular. The way that I've made these first, I think the miters on these are going to be fine, and we'll adjust the length of that center piece for the amount that these have screwed in, and we'll be fine. I definitely made the right call by waiting to cut that center piece, because what I talked about earlier, where the amount of threads, see on that new nipple where the new nipple went in, there's 1.5 inches of threads total, and only 3/4 of an inch went in there. On these used ones, you can see how it went in way farther, and that makes this distance in here shorter. And I think with different pipe dies, you just run into that. If you look right here, those threads have threaded way into there, and then you look right here and they didn't thread in so far. But there's a lot of different pipe dies that cut those threads, and they're tapered, so it depends on, I think, the degree that they're tapered or whatever, something like that. But if we look at this, we can tell that we're fitting real good on our angle. All I got to do is take my test piece and hold it right here, and then I'll take a measurement to see how much longer I need to make that, and I'll cut my pipe that long, and we'll be in good shape. The way I cut this in the saw, I didn't do any beveling on it. So I'm going to be probably just like one section at a time to start out. I'm going to be cutting a groove in there with my grinder and taking a 3/32 5P plus pipe rod and welding that section. I don't want to grind too much, do too much like that all at once. I just want to do a section. I'll do a section. I'll probably go straight across from there and do a section and do a section, because I don't want my tacks to come apart. Going a little bit at a time like this, it'll leave all the tacks in place that I've tacked on there, and I'll go straight across from each other, and I'm going to do what I can going straight across back and forth to keep from having this move from the way it was when I tacked it. So just putting one pass of the 332 pipe rod on there, and then I hit it with a grinder, knocked the hump off the center. Still got wagon tracks on each side of that bead, and normally you'd run a hot pass, a filler, and a cap with your pipe rod if you were welding this, you know, like code 1104. Since I'm going to rotate it and cap it with a 332 7018, I can go ahead and do that now, and it would hold the world. So that's what I'll do next. It's just going to end up being two passes. Put that root in like that with a 332 5P plus pipe rod, and then I'll cap it with a 332 7018. That'll be it. So nothing special on that, just pass a pipe rod, a pass of low hydrogen. But that welds like Emily. It's better than it has to be. My wife went walking up the road with the neighbor boy. They went for a walk. Right up the road from us is the stockyards. Right in front of the stockyards, they found a Nelly CD. Fell out of somebody's vehicle in the road. Well, which one of them farmers been listening to Nelly? Alright, y'all. We got her back in there. Fitting good, looking good, tightened up. Nothing major, but definitely something that looked to me like it needed addressed. And decided to probably post this one separate from the rest of the work on the bumper of the fire truck. Alright, y'all. Thanks for watching. What are you doing up there, Miss Diane? Built all this storage, I never even knew you, and never even knew that it's a pretty cool place to be a cat. Climb around in here and my stuff. I miss sweetheart. spot to be a cat.